This question here has us focusing on the techniques of integration. Now, something to remember is that integration is the opposite process to differentiation. They both lie on the same fundamental fact that in order to integrate a term or differentiate a term, it has to be written in the format y equals ax to the n. However, differentiation and integration work in opposite directions to each other. Now, when we're integrating, we write it as integral from x to the n dx. Now, a couple of things here. Firstly, the integral sign is like that. It's a curvy S. If you put it as a sum, it doesn't mean that we're using the exact same technique. Integration can be thought of as a sum, but if we write it in this manner, we can use this technique to just straightforwardly do it. Second key thing is the dx. That dx tells me which variable within my equation I am integrating with respect to. It is something we need because particularly if we have something with multiple variables in it and we integrate with respect to a certain thing, each thing we integrate could have a different meaning. So we have to be important, and it is important, sorry, and we have to make sure we bear that in mind. Now at this stage we're just going to stick with one variable in it, whatever that variable is. So in this case we're going to stick with x, but we still have to include it. Now as I said, integration is the opposite process from differentiation. So in order to do that, what we're going to do is we're going to raise the power by 1. Remember, differentiation, decrease the power by 1. But in this case, rather than multiplying by a number that comes from the power, what we're going to do is divide by this new power, n plus 1. If we then differentiated this term, what we'd end up getting is that n plus 1 would cancel out with an n plus 1 coefficient, and we'd end up getting back where we were. So at this time, divide. Don't fall into the trap. Remember, divide. There's also one other thing we have to make sure we include. That's called a plus c. This is what's called a constant of integration. Now this comes about from the fact that when you take the derivative of a constant term, you get 0. In the original equation, when I integrate back, I could have a constant in there, because if I then take the derivative to get back to my original function, just as a double check method, that constant could disappear. However, it could still have been present in the original. So we take that into account by doing a plus c. Sometimes I'll be given conditions so I can find the plus c, but we just include it in a generic integration question like this as part of the process. So first thing I need to do is write this entire integral in the format ax to the n so that I can integrate it properly. Now the first term, 2x to the 5, it's fine, it's written as we need it. This minus 6 root x we must write as minus 6x to the half dx. Don't worry about writing the x greater than or equal to 0 again, that's just taken as is. Then we go term by term, integrating each term on its own. So raise the power by 1, so it becomes x to the 6, and then divide by this new power. We then take away 6 times x, raise the power by 1, so 3 over 2, then divide by this new power of 3 over 2. Don't forget then at this stage, we put our plus c in. Make sure it goes in at this stage when we finish the integration for the first full time. Don't start adding it in later. Don't do your integration by stages. So don't integrate, for example, the first term, then write it out, and then do the integral again and get the second term. Do the entire thing in one go, in one sweep. What we then do when we get to this stage is we start to simplify things. So I'd end up this first term would become 1 over 3 x to the 6. Now remember, 6 divided by 3 over 2 is the equivalent of 6 times 2/3. So 2/3 of 6 gives me 4. So it's then minus 4x to the power of 3 over 2. Then my plus c. There you go. Final answer there at that point. So we just leave it there like that, and that's us laughing. Question like this, typically worth 4 marks. So for this one, I get 1 mark here for writing it in an integrable form. Second mark comes for integrating one term. Third mark comes for integrating the second term. And then the fourth mark comes from completing the integration and ensuring I've got my plus c. Please don't forget that, because it's a silly, silly mark to cost yourself and a silly, silly error to make, and it's not something we want. Remember, we want to gain as many marks as possible and avoid making silly errors and being a dafty by doing that. Okay? integration techniques. Nice question there for you to get a bit of practice on. 4 marks from it. Easy peasy, lemon squeezy.